A warm welcome to the 10th and the final episode of Holcim Awards webinar series, organized in collaboration with EcoGradia. My name is Dr. Priya Pawar, and I am the Holcim Awards Program Manager at the Holcim Foundation. The Holcim Awards have been organized by the Foundation since 2004 to support and empower change accelerators for sustainable construction. Over the past 2 decades, the competition has gathered close to 30,000 entries from 130 countries spanning 5 geographical regions. The 2023 cycle of the Holcim Awards received a total of 500 valid submissions. And from these eligible entries, 20 winners were selected by the distinguished panel of jurors. The title of today's webinar is Material Smart Designing for Low Carbon Buildings. And I am pleased to see that people from over 31 countries have registered to join the webinar today. To share insights on sustainability in their parts of world are two of our guests. First, Benjamin Scheerbath, who is the co-founder of Office Park in Scheerbath, Germany. Their project Haus 2 Plus won the Holcim Awards 2023 Bronze Prize for the European region. The second of our today's guests is Matthias Peterseim. Matthias is the head of project development and member of leadership board at Bolthauser Architekten in Switzerland. Their project high-rise H1 Zwhatt Site won the Holcim Awards 2023 Acknowledgement Prize in the EU region. Benjamin, Matthias, would you please join me?
Hi there.
Hi, Priya. Thank you very much.
Hello, welcome. Um, Today's session will be hosted by Dr. Nirmal Kishnani, host of the EcoGradia podcast, who is a leading author and educator in the field of sustainable design. Nirmal, would you also please join us?
Hi, Priya.
Hello, Nirmal. On behalf of the Holcim Foundation, we are delighted that you all could be with us today. Benjamin, you're presently in Germany. Matthias, you're in Switzerland, where for all of us, it's an afternoon. However, Nirmal, you're joining us from Singapore, where it is very late evening. As the webinar occurs in different time zones, for our host, guest, and our audience, we express our appreciation for your enthusiastic participation. Before I go, a word for our audience. There will be a Q&A session at the end of today's conversation. You may type your questions in the comment box. Dr. Kishnani will try to include as many as time permits. Nirmal, I'll leave the webinar in your good hands now, and I will see everybody later. Thank you.
Thank you, Priya. So, Benjamin, Matthias, it's a great pleasure to meet you. Let me start with quotes from the jury regarding your respective submissions. Matthias, the jury for Europe, in awarding an acknowledgement prize to the high-rise Zwhatt site in Switzerland, singled out the balanced and harmonious combination of timber structural elements with other materials such as concrete, clay, and truss lime. This deliberate choice, they said, showcased a commitment to sustainability while adding to the building's aesthetic appeal. Benjamin, the jury for Europe, in awarding a bronze prize to the H2 Plus in Germany, spoke of the project's commitment to low-carbon material adoption and smart construction systems, enabling rapid on-site assembly and ease of disassembly for reuse, which resonated with the jury's environmental sustainability principles. So before we start the conversation in earnest, please, could you each of you walk me through the project? Let's start with you, Matthias.
Thanks, Nirmal. Thanks for having us. I'm very pleased that we can present the project again. I will try to explain it in a few words now. The Zwhatt H1 is a residential high-rise in a suburb very close to Zurich. And at 75 meters, it's currently the tallest timber tower in Switzerland. It will house around 2,000 people in dwellings, as well as co-working spaces and a cafe in its plinth. This plinth, the base of the building, is, as well as the internal core, is entirely made of in-situ concrete, while the upper part instead is mostly beechwood. sourced locally from Switzerland, as you can see in these renderings. Right now, the building is still in construction, will be finished in under a year. The timber structure is already done, as you can maybe see in the last few images that we put here. The facade that you saw in the renderings also features horizontal photovoltaic modules that will produce more than 50% of the building's needed electric energy. Thank you.
Great. Thank you, Matthias. Benjamin, would you now summarize your proposal?
Yeah, with pleasure. Thank you, Nirmal, and hi, Matthias. The Haus 2 Plus is a timber addition for Berlin's Holzmarkt 25 cultural district. The Holzmarkt area along the River Spree in Berlin was once a central wood trading port in the early 19th century. It later became part of the GDR border zone and the vacant brownfield, and it transformed in 2003 as home of an iconic techno club. And in 2012, this legacy inspired the development of today's Holzmarkt 25, which is a cooperative cultural quarter attracting nearly 1 million visitors each year. Last year, we added Haus 2 Plus to this creative village, which is clad in bright red wood. And this 3-story structure now marks the main entrance, making a bold statement for sustainability amidst the patchwork of buildings there. Its distinct curvy shape is composed of a simple geometric volumes offering 6 units across around about 200 square meters, now home to a bakery, a tattoo studio, booking agency, artist atelier, photo studio, and a physiotherapist. Given the tight budget and the limited footprint, we maximized existing resources on site. So like a friendly parasite, we attached to an existing stairwell of a concert hall, minimizing CO2-intensive circulation space. Haus 2 Plus is constructed with 3 different timber systems. We use mass timber for internal walls, timber box elements for slabs, and timber frames for the exterior walls, and all are cladded in a timber facade. Everything is prefabricated regionally and is assembled on site with screws instead of glue, making it easy to disassemble and reuse in the future. So coming full circle, Haus 2 Plus is not only an extension of the cultural village, but it's also a tribute to Holzmarkt's heritage as a wood trading port.
Wonderful. Thank you, Benjamin. So let's start with the one obvious commonality between your 2 projects, which is the use of timber. I mean, the way this material is deployed in each project is, however, somewhat different. And this probably has something to do with the size of the project and the opportunities and limitations of the material. Haus 2 Plus is a 200 square meter mixed-use building in Berlin. Meanwhile, high-rise H1 Zwhatt Site is about 17,200 square meters residential tower in Zurich, 86 times larger. So let's break it down and talk about the choices you made and why. What do we mean by material smart? What specifically does this have to do with low carbon? Benjamin?
Well, probably the listeners of your webinar are well aware of the significant advantages that timber can have in terms of carbon emissions as compared to reinforced concrete structures, at least the conventional reinforced concrete structures, also appreciating that there is major research in concrete. But the traditional way of building with concrete and steel, there are major sources of GHG emissions and don't have carbon sequestration, so carbon storage potential, whereas timber has. As you said, the projects from Matthias and I, or from Bolzhauser and our office, couldn't be more different. At the same time, we both chose timber. For us, we only have a 3-story building, so we can use sort of traditional building systems as well. So for the exterior walls, we chose a timber frame construction. And the timber frame construction has one of the lowest median carbon intensities that you can find. It's between 120 and 200 kilogram CO2 per square meter. I believe concrete has between 300 and 400. So we did an LCA analysis and we found that for Haus 2 Plus, overall, cradle to gate, we have 217 kilogram of CO2 per square meter, which I believe is pretty low. Also, in our benefit is that we didn't have to pour concrete for circulation. We're attaching to an existing staircase, and we didn't have to pour concrete for a foundation because there was already a basement built underneath.
So there were some side advantages to your project. Matthias, I mean, walk me through this a little more. We hear the word embodied carbon used very often in the context of buildings. And so what Benjamin was talking about was the embodied carbon within that. Could you break it down a little bit? What is embodied carbon, and how does that factor into the conversation that we're trying to have?
I guess adding to that what Ben already said, the general overall idea of embodied carbon in construction industry would be you take the carbon that was gathered in the forest by the trees, you take it out of the forest and you store it in a building. Instead of leaving it in the forest, where after the lifespan of the tree will rot and release the carbon dioxide to the atmosphere again, you take it out of the woods. Of course, you regrow the trees and you store it in a building for the lifespan of the building, and then afterwards you probably reuse it or release it after a longer time span. And that way you have like a carbon sink inside of our built environment. It's like a second forest.
Right. So material selection becomes a big part of how we build smart for low carbon construction. But the skeptics will say that timber comes with other problems, right? I mean, it's advantages from a carbon standpoint, but it doesn't have the strength of steel or concrete, and therefore it has some structural limitations. It is perhaps more inflammable or prone to fire spread than the other materials. Talk me through some of these considerations in your approach, Benjamin.
Yeah, I think importantly, timber buildings can easily be designed to meet the same structural performance requirements of concrete and steel. I think that is not a problem. And the project from Bolthauser is a fantastic example of that being true in combination and in really smart detailing also on the high-rise scale. In fact, for this low-rise project, our Haus 2 Plus, we wanted to go one step further, and we wanted to prove that even with prefabricated timber, one can achieve a complex form, right? So our building is not a box, it's not a rectangle, it is quite complicated in a way. And we wanted to prove that not only can timber be designed to have the same structural performance requirements, but it can also achieve these complex forms. Sure, the volume to weight ratio sometimes is larger. Sometimes you need more volume to achieve the same strength. And there enters the topic of sufficiency, material sufficiency, right? But not every timber is created equal. There's also engineered timber products that go a long way to achieve fantastic weight or even volume to strength ratios. The ceiling slabs that we chose, they're actually from Switzerland. It's a proprietary product called Lignatur, and they're hollow box elements. And I see Matthias nodding. So these are elements that have wonderful performances for strength and weight. And well, before we get to fire, maybe I open it up to Matthias.
Matthias, I wonder if you could maybe expand on some of the terms that Benjamin mentioned, like CLT and glulam and mass timber. What is that, and why is that taking the conversation on timber forward? I mean, in terms of strength.
I think what we have to stress with both of these projects is that they are by no means traditional timber constructions. They do not rely on traditional timber building techniques. They both use modern researched products, such as the Swiss one, slab one that Ben mentioned before, that is also designed to resist fire and so on, which is a requirement, especially in high-rise buildings. We face a lot of challenges regarding fire protection when building a high-rise. So you need these newly designed products in order to do this. Like, I think this all started almost 30 years ago when the first people were interested again in timber construction, especially in America and Europe. But I would say probably at that time in the 19s, you couldn't have done both of these projects in the same way. It's a progress, and it needs a lot of development. In the case of the Zwhatt high-rise tower, we used it's not glulam, but it's both the beams and the columns are made of beech wood, but not as like a mass timber one, like you just take the trunk and you put it there, but it's sawn, but not in small, how do you say, not like veneer that is glued together, but sticks. And you get these square dimensioned sticks and you glue them together, which is more efficient in terms of the amount of glue that is used, which is, of course, you need that for the bracing and so on, but still adds to the negative side of the ecologic footprint. So we wanted to reduce it and decided to use this Swiss product, which is this sticky beech product.
But the basic idea is that where timber lacks tensile strength, right? By creating these composite panels or elements, you kind of overcome that limitation. The compressed laminated timber columns or slabs or glulam, anything that kind of creates a composite of multiple timber elements actually is stronger, and it gets closer to what concrete and steel can do. Is that right?
That's totally right. Actually, in the background of my screen, you see there is a model that where we tried in another project to design a high rise, even a higher one, completely made from timber. Even the bracing and the central core, everything, the circulation, everything was timber. It is possible using these high performance products, but they need much more space. And this is one of the limitations that Ben already mentioned. You need more volume to reach the same goals. And this is probably a natural limit of these products right now. Because if you imagine you have a floor plan for offices, for example, how much space do you need for the columns? Steel compared to timber. And when you have in this one, you had like 60 by 60 centimeter columns or even more. And then the bracing going through the facade, and that's a lot of light that you're losing, a lot of floor area that you're losing, and these are also some parameters that make a building more efficient or less efficient.
What about fire? I mean, the fear that timber is more prone to spread of fire. How is that overcome, Benjamin?
Yeah, it's one of the most sticky misconceptions still. I think the largest enemy of timber is probably water and not fire. But I think timber has, and I'm fully with Matthias here, we're talking about this new age of timber, of engineered timber, has the advantage that the burning rate can be calculated. So it's a predictable burning rate, and there's a protective layer of char that is forming also. So it is a burnable material by definition if it's not encapsulated. But in terms of fire protection, it can actually sometimes outperform concrete or steel because of its predictable burning rates, right? So again, Haus 2+ is a tiny building, but let me share this anecdote with you. We're attaching to another building, which is called Haus 2, hence the name. And that other building, Haus 2, is a concert venue. And the staircase we're attaching to is an escape staircase, right? So we're attaching to an escape staircase of a concert venue. So the fire code and fire requirements are extremely high. But we still managed to build even the attaching wall with wood. Yeah? So it's possible. But code is still lacking behind, I think, technical innovations, and probably Boltzhauser can talk much longer anecdotes about that. But so for smaller story buildings, the code is in Germany largely caught up with technical innovation. But for instance, we had the requirement to put a fire protection door into the wood wall. But no fire this scenario is not covered by any sort of general type permit. It just doesn't exist, that scenario. So the only way to overcome it is we actually had to build drywall portals around the fire protection doors in order for them to be put into a timber wall. So there's still these little hiccups in the regulatory code, where we're trying to play catch up.
Right. There is this expectation that if it's locally sourced, should, at least in theory, cost less and maybe tap into traditional construction skills. Now, is that true? I mean, did you do a cost comparison of your project, looking at how it compared with other options? Matthias?
Of course, that was done. Maybe I have to describe a little bit the history of this project. It was a competition at first, a public competition where it was not necessary to make it out of timber in the beginning. But the jury and the client, they chose this project to be executed. And right from the beginning, it was clear this is going to be a little bit more expensive. But and there are other aspects that are more beneficial. For example, the pre-fabrication process means it can be built faster. The foundations, for example, of the whole building are smaller because the structure is lighter compared to a traditional steel or concrete construction. So you have to do this comparison, but we're really lucky that in the end we found a client and also contractors that were willing to take the risks. Also with everything going on in the world during the construction time to realize this building. In the end, we say right now, because the industry isn't as big as the concrete industry, and I think that is the problem, it's still about between 10 and 20% more expensive than the traditional structure. But then there are other means you can change about these buildings so they get cheaper on the other end, and then you can achieve a feat like this.
Right. I mean, you mentioned earlier that this is a whole new modern way of thinking about timber, that it doesn't necessarily, it's not a traditional building, right? I mean, Benjamin, are the skills for constructing with timber alive in the construction sector of your country?
I think very much, because the DACH region, like we call it, the German-speaking countries, Austria, Switzerland, Germany, that skill set I think is very much alive, because there's also a long tradition to build with timber. I think both in the traditional way and in this new and modern way, I haven't really seen a skill shortage in that sense. Yeah.
What about the other concern? You mentioned the biggest enemy of timber is not fire but water. Is timber problematic over time? Does it take more to maintain? Do you have to take special care? Does it take a little bit more attention over its lifespan? Matthias?
I think timber, for most people not familiar with the topic, is a new material, even though it's considered to be very old, something you use in farmhouses. But there it behaves very differently from other materials. Maybe an anecdote, how houses in Venice are standing on top of timber columns that are submerged in the water. So they are in the water for hundreds of years and they do not rot because there's no oxygen hitting them. So, but then there's moisture, and moisture is an enemy and will also affect the static abilities, structural abilities of the material. So for us in this project, it's less about what's happening in the future, because right now when you got the building envelope all around, it's protected. What do you do about moisture while the building is being constructed, while you put the beams and slabs in place? When it rains, for example, what do you do? So we always had to find a way to protect the construction site from moisture and put the facade modules, it's a modular facade, right in place at the same time as the structure itself. Usually you would build a skeleton of concrete or steel, and then the facade rises up sometime later, some months later maybe. But in this case, it was really critical to place the facade modules very shortly after the timber elements were placed in order to protect it from the elements. But once it's all finished, and I don't think there's a problem with internal timber at least. So the facades, also because of fire regulations, on the outside are still not timber.
No, I'm in the tropics, right? So we have a particular paranoia about timber buildings and exposure to climate, weathering and rotting and mold and so on. So I get that timber that is interior to the architecture is protected from the elements. But what about the facade? I mean, weren't your buildings also constructed of timber on the facade, Benjamin?
Yeah, we wanted, we had the luxury to be just a 3-story building. So we had a little bit more liberty to have the building not only be a timber building, but feel like a timber building. And in order to feel like a timber building, we brought timber to the facade and also had it visible inside. And the facade will undergo a weathering process. I think that is a normal situation. We don't have the humidity situation here that you have over there, but the facade will still weather. We had stained it for additional protection, also for the aesthetic as you have seen it, but we are also expecting to restain it every say 3 to 4 years. We see that as part of the necessary care that goes into it. But we also struck a deal with the contractor to store additional facade planks for the next 5 years, so we can also exchange some.
You've got some in reserve.
Exactly.
Right. What about the thermal performance of the material, especially when it's used as an envelope skin of the building? I mean, is it a good material from an insulative point of view when you want to keep the heat in, or in the case of the tropics, when you want to keep the heat out? I mean, it has a high thermal transmission value, no? Matthias?
I think everybody familiar with timber buildings knows that what all these buildings are missing, are lacking, is a substantial amount of thermal mass. Something that we have with concrete buildings, but also with historic stone masonry buildings. When the sun is in the summer, in the winter case, in the European sense, let's say, when the sun is hitting the facade or the thermal mass, it will heat it up and will save some of this energy and release it afterwards. And it's the other way around in the summer. That's something we don't get with timber because of its density. It's not as dense, it's not a mineral. So you have to add this or compensate for it with technical measures. In our case, we still have a concrete core, and we also have slabs that are part timber, part concrete. So the top part is concrete actually, but also for physical reasons because of the the noise reduction between 2 floors. You need that mass in order to don't make everybody feel uncomfortable because of the noises of your neighbors, and this comes in handy also for the thermal mass. That's why also we're always trying, like in newer project, trying to look for ways to combine both of these worlds. That's why we always talk about hybrid structures. Timber is a nice material. It's very interesting for certain use cases, but not for all. So sometimes maybe it's better to think about a combination of materials in a building and not do it only from one.
Right. I want to come back to this idea of the hybrid building. I think that's really fascinating. But before we do that, there is, I think, Benjamin, you mentioned making the material visible. There is definitely an impact on the occupant's experience when a building is made from natural materials. We call this biophilic, design, where you feel differently when you are in close to nature and or natural materials. let's talk about what that visibility has meant to your project. Uh, so, Matthias, I mean, yours is a residential project. It's obviously on a commercial footing. Has it got better return on value? I mean, are the rentals or the sale prices a little bit higher because it's made of timber?
I can't still comment on that, but if you like, you could come visit the building. You can actually hug the trees inside. If you like, it's a biophilic design in that sense. They're very large, the columns, and when I saw it for the first time, it's a really surprising effect, because it's one thing designing this. You see it in the plan, you see it in the details in the drawings, but then it's not a traditional building. Maybe there's some temple somewhere with these dimensions of columns in timber, but we're not used to seeing that, also touching it and so on. So I think it will certainly have an effect on the people living there, especially because it's a high rise, sitting in the 18th floor, looking at the Swiss mountains, and then you have the timber columns and the timber beams around you. It's a very special architecture. Also, usually timber is linked to a certain kind of lightness, let's say, and in this case, it's this. If there's another effect, because you have another dimension of timber, it becomes also massive at the same time. So. But regarding that return on invest, we have to wait for a little while still.
Fair enough. Benjamin, how do we get a sense of what the value proposition here is? I mean, there is carbon, there are upfront cost issues and upkeep issues, but ultimately it comes down to the way people feel about that building. You know, how much they value it. Is there a way of making a judgment of what that is, or how much value this idea brings to that particular architecture?
Right. The way we chose, at least, was to go back into the building a couple of months after it was finished with a documentary photographer. And we documented how the tenants, and I mentioned before, there are 6 tenants that are wildly different. Importantly, these are non-residential units. They're, in the end, cultural or commercial units, but from a bakery to a tattoo studio to a physiotherapist. And we went and documented how they had appropriated the units. And in the end, there's very few things that those units, I wish I could show you the photos. They look wildly different. Everyone has expressed themselves quite creatively, but no one has touched the timber ceilings. That's the one element that sort of combines all these units together, but also is a proof that that's a non-negotiable. That's what everyone loved. You know, some people have painted the inside just as red as the outside. It's an idea we would have never had and not recommended either. But everyone seems to love these timber ceilings. And of course, another way to measure it, and an important way to measure it, which we haven't done, but I would recommend at scale, is obviously to measure air quality and consider the effects on health and the effects on well-being that natural materials such as timber, but also clay in the interior space can have. I think that's a very serious issue, and it's still a little bit not under-researched, but there could be more interest, I think, also in the commercial sector to really provide healthy indoor climates, and timber is a key way to do that.
We in this conversation on how people value their environments, we talk about livability, but also lovability.
Wow.
And lovability has a long way to go towards ensuring the life of a building, because if you love it, you're less likely to tear it down.
Yeah.
But let me ask you another question about timber that often gets cited: deforestation. So there is in a podcast I did earlier with an architect, there was this feeling that, well, if everybody starts to do this, very soon the Amazon forest is going to be used to make buildings across the world, and so deforestation is a very serious issue. How was the material responsibly sourced by you in your project, Matthias?
That's a tough one. Let me think about it. As you already mentioned in the beginning, the beechwood for this project comes entirely from Switzerland, was sourced in Switzerland. But since the industry, especially for the building sector, isn't as big as it needs to be for this sustainable transformation, the client actually had to decide sourcing the necessary material very, very early in the project. Otherwise, it wouldn't have been ready when construction started. That was a problem. So there was not enough, you could say it like this, there was not enough beechwood available in Switzerland, sourced locally at the time the project started. So they really had to build this up. Also, the technology involved producing the elements had to be built up. So also this, I think you could say it's a pioneer project in that regard. But deforestation, I think, when I remember it correctly, in Europe at this point is not a problem, at least not anymore. When they started this sustainable forestry some 100 years ago, actually I think in Germany, forests over the last 30, 40 years were regrowing. But now with climate change really keeping us up at night, it's going worse again. So forests are dying, and of course that's a discussion that we have to talk about in the future.
Ben, I mean, how was the material sourced?
Interestingly, the same as Matthias, we had to reserve the material way ahead of the time of using it. And I think we might have done it at similar times, Matthias, because there was not only COVID-19, it was compounded by the Russian-Ukrainian conflict that we have here in this region. And we know that the timber market is profit-driven. And at this point, there was a shortage in timber. At the same time, there was different markets that were paying more for timber than Europe. And that was, I think, the US bought a lot of local timber. So if you wanted to build with local timber here in the region, you had to, it was quite hard to get the material. And I think these profit-driven markets, as you know, that will unlikely change, but there is a tendency that cropping can be too rapid, potentially, and that ore sourcing can happen from markets that are not as well regulated as potentially some European forests. So I think those are things we have to address. However, if you want to be on the safe side, the minimum that I think one could do, and that's also what we did and Matthias did, is to source exclusively certified wood. In our case, it was FSC certification. I'm sure there are other certifications around the world. I think that's the minimum one can do. Yeah.
Okay. Staying with you, Matthias, Benjamin, I want to ask you about the whole idea of design for disassembly, because that was a point that was singled out by the jury, that the building is conceived to be disassembled. Explain what this means. I mean, what does it mean at the drawing board when you say you're designing for disassembly?
Right. There are two responses to that question. I think the first one is the timber frame construction traditionally doesn't need much glue. In this level of height, the timber frame construction is usually screw connected. So it's not a massive innovation to design a sort of an only screw connected building. But we really tried to do this with all the building elements because we were inspired, and that's the second part of the answer. We're inspired by a question of identity, in fact, because the client that we're building for, there are legends of Berlin nightlife subculture, right? So it's a very interesting client. And back in the 90s or the 2000s, our client was using, as an interim user, was losing vacant lots and vacant factories. And they're actually employing timber and recycled timber as they found it on the streets to build architecture without architects, basically. They were using timber structures to build, techno clubs, et cetera. But essentially what they were doing is they were using wood in a way that they can use it for themselves and reuse it for themselves every season. And so we wanted to build a building in a way that it can be completely disassembled and reused on site without any special training. And we're quite confident that our client is able to do it. We don't want them to do it, obviously, now, hopefully not in the next 50 years, but the building is designed so it can be done.
Well, what does that mean, though? I mean, you mentioned not using glue, but in that very early conceptualization of the building, then you have to begin to think of the standardization of parts, the details. I mean, how does one begin to design for disassembly?
Right. I think most importantly, we decided to not use composite materials when possible, and that the building elements are easy to be disconnected. So with the exception of the foundation, which is quite minimal, and the screed that we have on every floor, I'm confident to say that the building can be completely disassembled into its parts. And that's I think through choosing no composite materials and taking care of these details or the connections. Yeah.
Right. Matthias, your project, you mentioned this as well, gets discussed very much as a hybrid project, which is to say that it's parts of it, in addition to timber, were concrete and other materials. Why not build 100% with timber?
Yeah, we will try again probably to do that because it's very interesting to also have these discussions with engineers. What are the things you have to do to make a high rise this size or even higher completely out of timber? And why haven't we done it before? That's an interesting question. And I mentioned the limitations that we faced before, and one of these is the amount of material that you need is just insane for high. Let's say you want to make a skyscraper, and we know there are some projects around on the internet somewhere where people want to make a 300-meter plus timber high rise, but we know that will probably be less efficient than making it from, let's say, reusable steel elements, because you need so much mass, so much volume of timber that maybe can't be even provided from our local forests, that you have some limitations there. Of course, then regulations, because in Switzerland, at least, high-rise buildings above 100 meters and so on, they face very, very harsh fire regulations at the moment. That can develop in the future. But still, in this case, it was also maybe that was lost in the description of our project. It's a hybrid construction. This is what H1, because in the plinth we have public use and an arcade and a cafe and offices, which with larger spans, and on top we have the housing part. The housing structure has much smaller spans that allows for timber construction, and we had to equally deploy the loads of the top part to the foundations. Why we needed the table, the concrete table underneath, and it's also a way to make a, let's say, urban public gesture, to have the let's say traditional large pillars that form an arcade on an urban scale. That's why it's hybrid.
Do you know what will happen to your building at the end of its life?
When would that be?
Whenever. I mean, I know it's a little unfair to ask you this because it was never meant to be designed for this assembly. But do you know?
You can actually disassemble it.
Can you?
At least the timber part could be fully disassembled, and also reused. I think one thing about when we compare it with concrete skeleton projects, construction, you can you don't have to upcycle, downcycle, recycle the wood. You can also reuse it just like regular steel beams. That's a way to do it. Or in the end, as I said, it's like an urban forest. You store the carbon for, let's say, 100 years or even 150, and then you burn it for energy or something. But you still kept the CO2 for a longer time that it would have been kept in the actual forest.
Right. I always ask this question at the end of every webinar, which is, how would you have done it differently? Any thoughts looking back, Benjamin?
Matthias, if you have one already, please please jump in before me.
Actually, I cannot comment on that. It's not even finished yet. So
that's right. So there was no major. So we're open for a year now, and there's no major issues.
Right.
But I think if I may critique our own building, but in a way it was also intentional. So what I want to say is this building is ultra complicated and complex. It has a lot of details which speak against the idea of efficiency, for instance, right? Obviously, that was done consciously because it's a cultural project and it sort of has a signal effect at the main entrance. But if one wants to build efficiently with the material and really drive these efficiencies, then I think one could build differently. And the project from Bolzhauser, I believe, is a prime example of a project that looks beautiful but also drives these efficiencies of timber. Yeah.
Okay. Thank you. I'm going to read out some questions that have been streaming in from the audience. Here's one from Annie Nguyen. She says, what models of collaboration are needed to implement efficient hybrid construction? Matthias?
I'm not sure if I get the question right, if I understand it right correctly. When we start these kind of projects, we collaborate with other experts very, very early on. So from the first day, if you want to make a timber or hybrid construction building, you need consultants on it. Because as architects, you can't know everything about it, so you have to start to collaborate early on. And also, like it was the case with the H1 tower, also need a client who's willing to do that.
But I can see where the question comes from in that, the kind of traditional way of thinking about buildings as structure and skin and fit out, these boundaries dissolve a little bit with this approach where the material is structure but also interior finish. I mean, I think there is a dissolution of boundaries between the layers we conventionally expect of buildings, and then they get assigned to different actors in the process, the structural engineer and the architect and the interior designer. Benjamin, I mean, I'm wondering, because you talked a lot about how it's 100% timber and the ceilings are made of timber and the facade is made of timber. Was there, to build on that question of collaborative thinking or a different process that needs to anchor this type of thinking?
Yeah, we engaged a timber contractor from the very, very early phases. And at least it felt like there was also something that was easy to do. The contractors felt open also to share knowledge. So before even deciding on one, we engaged with one from very early on, and they ended up to also be the contractor. We couldn't have done it without this early engagement of the contractor and of course the structural engineer. Simply because we as architects didn't have enough knowledge on the material ourselves, and because we had this complexity of detailing the half barrel roof and the overhangs and things like that. But collaboration is key. I think the challenge potentially is that there are certain fee structures that don't reflect this additional planning effort that goes into building sustainably, because I do believe it still has an additional planning effort that usually pays back afterwards. But I think there's some room left for improvement there.
Mm-hmm. Yeah, that's a really interesting point. Um, on the question of cost and fees and so on, here's another question, and this one's from Priya, who's in the backstage. She wants to know. She wants to know if the higher cost of construction gets reflected in the cost of occupancy. I mean, do occupants understand the benefits of low carbon materials? I mean, maybe Matthias, your project is not completed yet, but the conversation that's happening in industry, are occupants, are they cognizant of what's being done and prepared to pay for it?
Yeah, let's see. I hope it will, but I don't even think that should be the goal, because doing sustainable construction, sustainable building, is not about. It should be a standard at some point, and we also need regulations and politics to push forward. Right now, it's a challenge. It's a tough one, and we like it, and we love it when people respond. In a positive way to it, but I think you can't, like, in the next few years, calculate with values like that.
There's one last question here from Sarah Ganesh. I know neither of you are working in the tropics, but she's asking the question, and I'm curious as well. To what extent can timber construction be successful in the tropical context? How far have we come, and how far do we have to go? Do you have any thoughts on that, Benjamin? Have you had any exposure or experience?
I don't, and I know as soon as I put that question into Google, there'll be a better answer than the one I have. But I also know, but what I do know is that there's other natural materials that are not timber, but there are still alternatives to to concrete and steel that potentially fare very well in the tropical context, such as bamboo, for instance.
Right. Matthias, any last words on that?
I'm not sure. It's probably, if you think about it, there are at least historic buildings in a tropical context, so there should be a way. I don't know what to do and what's the way, but there should be.
Yeah. Well, I mean, for what it's worth, there are a lot of experiments taking place in the tropics, and I think in Singapore there's a full timber office building, one of the largest here. I mean, everyone's kind of waiting to see how it goes, because it, there is a difference between what happens on paper versus what happens in real life, how a building fares. So the jury is out on that. But thank you guys. It was great fun talking to you both and getting your perspective on this. I'm going to invite Priya back to the stage for her closing remarks.
Fascinating perspectives. Honestly, it was so enlightening to understand what's happening in this part of the world, and how hybrid construction has been approached in different ways at different scales. So, before we close today's podcast, I thank you all again, Benjamin, Matthias, for sharing your insights and giving us a peek behind the curtains to your two amazing projects. Um, I also have to say many thanks to Nirmal and the EcoGradia team, Kelvin and Sana, for hosting this webinar series. I'm taking a little bit of time to say thank you to all of you, because today is our last podcast of the series. And I must say, we've enjoyed this collaboration. And I would say also our audience has benefited a lot from this initiative. So, Nirmal, thank you for your great guidance.
Thank you, Priya.
Thank you. Besides that, I want to say that we hope that our conversations have sparked new insights and inspiration to for our audience. So let's continue building a more sustainable world together. And finally, for our audience, the next cycle of Holcim Awards, Holcim Foundation Awards 2025, is now open until February 11th, 2025. You can get more information regarding the awards and eligibility criteria at awards.holcimfoundation.org. Besides, we are also hosting an event in Berlin. So if you'd like to meet the team of Haus 2 Plus, as well as the Holcim Foundation team, along with sustainability experts like Sven Fu from Graft Architects, please join us at the Holzmat 25 in Berlin on 25th of November 2024 from 6 p.m. onwards. Benjamin's partner, Mujin Park, would be talking to us on the project. So she'll be a part of the panel. More details for registration is available on holcimfoundation.org/awards-talk-Berlin. With that, I bid all of you a goodbye and hope to see you all again soon next time. Thank you.
Bye, Priya.
Thank you so much.
Bye-bye.